So here we have question 3. The class version audio went out, so I am redoing it. Let's see if I can do it maybe more directly and such. So this is a question dealing with linear programming. So this was from 6.1 and 6.2. And one of the things you'll need to be able to do for the exam is to set up the solution set. For linear programming, we're going to have constraints. These are limitations on our resources, so we're going to look at for those. And then we're always going to need an objective function. The objective function is what are we trying to achieve, and if we look up here, it's usually something about we're trying to maximize profit or minimize cost, something along those lines in a business situation. So what are our constraints? We come here. Again, I like to read the last part first. How many of each should be accepted to maximize profit? How many of each? Each what? Well, we come up here. We've got a parking lot has 600 meters. Underline that. Car requires 6 square meters. So car, that's one type, and a bus. Car and bus, that's probably what we're looking at. A bus requires 30 square meters. The attendant can only handle 60 vehicles. If a car is charged $250 and a bus $750, how many of each should be accepted for the profit? Okay, so setting it up, constraints. We have a limit on the amount of space in our parking lot, 600. So whatever we do, we cannot use more than that. We've got to use less than 600, less than or equal to 600 square meters. We're told a car requires 6 square meters. So we might over here say, well, let's call X number of cars, and we'll call Y the number of buses. So we've defined our variables. So 6 square meters for each car. So 2 cars would be 12, 3, and so forth. So I'm multiplying 6 times X. And then for buses, bus will require 30 square meters. So that's going to be 30 times Y, however many buses. That will give us the amount of space used. We're told that the attendant can only handle 60 vehicles, whether it's a bus or a car. So that tells us that X plus Y has to be less than or equal to 60, because we can't get more. If a car is charged $250 and a bus $750, how much? So this is dealing with not really profit. I would call this revenue. For profit, you have to subtract off costs, right? And we aren't given any information about cost. But anyway, the objective is each car, the income will be $2.50. That's times each car. And then we're going to get $7.50 for each bus, and that will equal our revenue. Okay, it's a function of X and Y. So that's a third variable. So that's really setting up the problem. We've got the problem set up now. And then we're going to use part A. How many of each should be accepted to maximize profit? What is the maximum profit? So in doing the problem, what we're going to do is we are going to graph the constraints, and notice they're inequalities, so they will be shaded, and we're looking for the feasible region. So this first one, how are we going to graph it? Well, we're going to solve it for Y. So we would subtract 6x from both sides, right? And that's going to leave us with 30y is less than or equal to 600 minus 6x. Notice how you could just sort of move it over there by changing the sign. We need the y by itself to be able to graph it on a TI-84 calculator. If you can graph it, if your calculator may work differently, but so we're going to divide everything by 30. And over here, just because the calculator can handle all of this, we're going to divide this by 30. So we get y is less than this. This is what we will put into the calculator. For the second one, we need y equals basically. So we subtract x from both sides, and we're going to get that y is less than, and this is the second one, 60 minus x. Now I'm also going to put parentheses. We could divide by 1, right, because there's a number here. Division by 1 doesn't change anything, so we don't have to, but these are the two equations. So I'll put this as y1, we'll put this as y2. So we come over here, hit y equals, and we're going to put in the first one, 600 minus 6x. And please do practice with the graphing calculator. I've got students who sometimes a day they borrow it from a friend, and then they try to learn it in like one day, or they think, oh, I'll just show up and I'll ask, how do I do this? You need to know how to use the calculator in advance. This is part of the learning process. You need to know how to use the tools. 60 minus x. So those are our two constraints. And I guess, really to set it up fully, we come over here. The other constraint is that both x and y have to be positive. So x has to be greater than or equal to 0. You could have 0 cars, but can't have negative cars. And buses have to be greater than or equal to 0. So I'm going to put one more in here. We're going to put in y equals 0. Now I didn't do the shading part, so let me come back here. So I arrow over, and again, each calculator works a little differently, but I want it to shade. Since I have over here y is less than the function, I want the feasible region is below whatever line this ends up making, right? It's below the line, so I shade above the line because that's how the textbook does it. So let's see, I think I hit enter, and then I have to come down here, and I'm going to change to the shading. I'm shading above. Enter. Okay. Same thing for the second one. Y is less than it, so I want to shade above. So I hit enter, and there. Now with y is greater than 0, I want above, so I shade below. Okay. Here we go. Oops. Oh yeah. No. There we go. That's the one. Okay. So this should give us our feasible region. For our window, let's see, we can't have basically x or y could be 0, the other one could be 60. So the area we need to be able to see is, we don't need to be able to see beyond 60, but let's go to 65 just so we see everything. And then x minimum, it's 0, but let's go to maybe -5 so we again can see a little bit to that side, just in case, and then maybe go to 65. Okay, so this is setting up a window where we'll be able to see everything. So minimum x's, that gives your left and your right of the window, and the y minimum gives the bottom of the screen, y max gives the top of the screen. I'm going to graph it, and sure enough, I can really see everything. The only thing I couldn't do is x less than 0, because TI-84 doesn't graph vertical lines. So far, you could sketch this, I guess, if you needed to, but be able to recognize that this is our feasible region, and again, that this little area over here should also be shaded. What we need now is there's 3 points. There's one here, here, and here. I guess there's 0, 0 as well, but that's probably not going to give us a maximum revenue. If we don't have anyone come, we're not going to make any money. So, I mean, you could check it, but there's these 3 points here. Okay, so we need to find these 3 points. So finding this first one here that is on the x-axis, let's go to second calc. So calc is above trace, and I'm going to go with value. Okay, I'm going to enter x equals 0. That'll get me to the y axis, and notice if I go up or down, it could give me any of these. The one I want is this one here, so make sure you get it. So 0.20 is a potential solution. So this is what I'm going to do. I'm going to find those points. One of those points will be it, and then I'm going to plug the point into here to get the output value and see which one is biggest. Okay, so that's that point. I want this intersection between these two lines, so I go second calc, intersect, and I want to be along this line, which I am. I'm just going to hit enter. It jumped up to this line, which is a line y2, 60 minus x. You can see that up there, and that's the second line I do want to be on, so I can just hit enter. And then if it asks for a guess, I can just hit enter, and it's going to find the intersection of those two, and it finds it right there with the little flashy guy, and it tells me that's 50, 10. Okay, so here's another point: 50 cars, 10 buses. That's a possibility. And then there's a final one down here, and again, that's going to be the intersection of y equals 0 and the y2 that I'm on right now, so the intersection of y2 and y3. So I can go second calc, intersect, and okay, I'm on the blue one. That's not the one I want to be on, so I'll hit either the up or the down arrow. Okay, now notice I've gone to y2. It might not look like it, but you could, if you go left or right. Oh yeah, that's the one I'm on. That's the one I want. Enter, and then I want y3 as my second curve, and that will give me my intersection. Enter, enter, and it does. 60, 0. Over here, 60, 0. Now, in class I was thinking this would be the biggest one, but there's also this, well, yeah, because of the total. Anyway, what we'll do is we'll plug in each of these to this function, and we will see if which one yields the largest. So 0.20, 0 for x, so that's 2.5 times 0 plus 7.5 times 20, so that would be all buses. That would be the maximum we could get, and that's going to give us about 150. Yeah, so this gives us, I'm going to put it over here, 50 times 10, so that's 2.5 times 50 plus 7.5 times 10, and that gives us 200. And finally, we'll have 60, sorry, 2.5 times 60 is the way we're plugging in the 60, right? Plus 7.5 times 0. So 2.5 times 60 gives us 150. So here is our maximum solution. 50 cars, 10 buses, give us a total revenue of $200. Okay, so that's how we can do it. If they asked us to minimize like cost, we would do the same thing, exactly the same thing, but we would be looking for the smallest number. So that's the difference between maximize and minimize. All right. Thank you.